The adrenal gland is on top of each kidney. It is made up of two glands. The adrenal medulla, or middle, is regulated by the nervous system, and the adrenal cortex is the crust, or outside, and it is regulated by hormones. The adrenal medulla produces epinephrine, or adrenaline, during stress, so it's part of the fight or flight response. It increases blood glucose by causing liver to convert glycogen to glucose. It increases heart rate and blood pressure, increases breathing rate. Blood vessels dilate or get bigger, and that's specific to the areas that you need to either fight or run away, so arms and legs. And pupils dilate. It is stimulated by the sympathetic nervous system. Now, this isn't just if you are running for your life, but it could also be just stimulated in general. So writing a test, being more alert, running, playing sports will all stimulate the sympathetic nervous system. Adrenal cortex releases two hormones that start with A and cor, aldosterone and cortisol. These are both stimulated by ACTH from the anterior pituitary. Cortisol is released during long-term stress. It's also released if someone is injured. It's anti-inflammatory, which means it's also anti-immune because the cells that cause inflammation are the white blood cells, so it prevents them from dividing. It has another function. It targets the liver and muscles. It increases levels of amino acids in the blood to help the body recover from stress. The liver converts amino acids into glucose for more energy. So does cortisol increase or decrease blood glucose? Well, the liver is converting amino acids into glucose, which are put into the bloodstream, so it increases it. Hyposecretion can be a result of Addison's disease, and hypersecretion can be a result of Cushing syndrome. Can stress actually kill you? Click on this link to see. Addison's disease results in weight loss, low energy, low blood pressure, and occasionally areas of hyperpigmentation of the skin. Cushing syndrome includes having a moon face, osteoporosis, a pendulous abdomen, bruise easily, and these striations. Cushing syndrome is due to hypersecretion of cortisol. It could be a tumor in the adrenal cortex. Let's draw the flow chart for epinephrine. The reason it is not a negative feedback loop is because it is stimulated by the sympathetic nervous system. So short-term stress would cause the sympathetic nervous system to directly stimulate the adrenal medulla, which releases epinephrine, which has a variety of effects, including increasing heart rate and breathing rate. When the emergency is over, the sympathetic nervous system just stops stimulating it. It is not a negative feedback loop. Long-term stress results in the hypothalamus releasing ACTHRF, which goes to the anterior pituitary, which releases ACTH, which goes to the adrenal cortex to cause release of cortisol. And then cortisol has a negative feedback effect on the hypothalamus and the anterior pituitary. Let's compare aldosterone and ADH. They're often released at the same time. ADH specifically is released in response to dehydration. Aldosterone is released in response to low blood pressure. So one time they would not be released at the same time is if someone had a salty meal. Salt means that the blood is hypertonic, and so only water is needed to dilute that. Aldosterone would not help because it causes the salt to stay in the bloodstream. To watch what happens if you stop drinking water, click on this link. Bill Gates talks about water that is created from poop in this clip. Okay, aldosterone, let's remember the S in aldosterone for sodium. Aldosterone targets the kidneys to increase sodium retention, which means in the blood, and water follows by osmosis. It's similar to ADH in that they both increase blood pressure. It results in lower volume and more concentrated urine. Hyposecretion, so not enough, would result in water loss or dehydration, and too much is increased water retention or high blood pressure.